Modified Adomian decomposition method for the Fredholm integral equation of second kind. Previously we did the same method for Volterra integral equation, but right now we are going to solve it for Fredholm integral equation. The given integral equation is Fredholm because the lower limit and the upper limit, both limits of integration, are constants. And this is second kind because the unknown function u is appearing both inside the integral and outside the integral. So this method is applicable only for the second kind. And the same method, modified Adomian decomposition method, is used to solve the Volterra integral equation as well. That is shown in the previous video. Now let's solve this. For the modified Adomian decomposition method, you have to split your function into two parts. Let's take it as f0 and take it as f1. Now your u0, before moving on to to expand these series, we have to let the series, that is u of x, is sum from n is equals to 0 to infinity un of x. Now let's plug in these u of x here. We'll get sum of series from n is equals to 0 to infinity un of x equals sine of x minus x plus x times 0 to pi by 2 t sum from n is equals to 0 to infinity un of t dt. Now let's expand this series on the right side as well and on the left side as well. So we will get here u0 plus u1 plus u2 and up to so on, and we'll get here sine of x minus x plus x 0 to pi by 2 t, and here you are going to get u0 plus u1 and up to so on dt. Now let's expand this. When we'll expand this, we'll get here sine of x minus x plus x 0 to pi by 2 t u0 of t dt plus x 0 to pi by 2 t u1 of t dt plus up to so on. Now we can compare our left hand side with the right hand side. Just compare the first term with the first term, compare the second term with this second term, and this third term will be compared with this third term and up to so on. So let's compare these terms. u0 of x here is sine of x, u1 of x here is minus x plus x integration from 0 to pi by 2 t u0 of t dt. Now this u0 of t can be replaced by this value, that will give us minus x plus x integration from 0 to pi by 2 t sine of t dt. Now we can simplify this integral by using the integration by parts method here. So that will be, the answer will be here u1 of x is minus x plus x. After applying here the integration by part, we'll get here sine of t minus t cosine of t, and limits of integration are from 0 to pi by 2. So first of all we'll plug in here the upper limit, then minus lower limit. So we will get here minus x plus x. First of all I'm using here the upper limit. Then you have to use a minus bracket and now put the lower limit, sine of 0 minus 0 cosine of 0. After simplification we will get here 0 as our final answer. Now let's find u2 of x. So u2 of x will be this, that is x integration from 0 to pi by 2 t u1 of t dt. Now let's use this u1, since it is 0, so it's making up everything as 0 here, so it's 0. And if we will find the u3 of x, this will also be 0 and up to so on. Now let's use all these values of u in this series to get our solution. So u of x is u0 of x plus u1 of x plus u2 of x and up to so on. And u0 of x here is sine of x plus 0 and up to so on. So solution of our question is just the sine of x, and you can even check it whether it is your exact solution or not. To check whether it is your exact solution, you can just use it here on the left side and right side. If both the sides answers are equal, then it means this is your exact solution.